in Bell Work today, we are solving differential equations, and we had the question, are they going to do this type of question a lot? Find the mistake. The only time I've ever seen them do this is on this question. So this is from Khan Academy. They know what's going on. It's the only time that I've ever seen find the mistake, but they will do it with differential equations. Show me your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What'd you get? We're getting some 1s and some 2s and some 4s. Let's see what it is. Okay, we're trying to solve the differential equation. What does it mean if I'm solving the differential equation? Get y by itself. We're trying to find y. We're trying to figure that out. Okay, so if we're starting with this one, the first thing they did here is they were like, all right, it's squared, so let's just make both things squared. Secant squared, y squared. It just allows us to then separate the y, because without that, it's really hard to separate. Okay, so step one, the separation of variables. How would I get rid of this y squared? Multiply by y squared, and then divide by dx, or multiply by dx. So over here, that's going to cancel. That's going to cancel. We get this. Y squared dy, secant squared dx. Step one is fine. They separated correctly. From step two, we separate. Then we integrate. Okay, when we integrate, we get rid of the dy. So we antiderivative of y squared. We add 1 to our exponent, divide by our new exponent. That's fine. What, when you take the derivative of it, gets you secant squared? Tangent x, great. They put this little c1 right here. Don't worry about the 1. It's c. It's plus c. We good there? Yeah, that's fine. Step 3 is fine. So step 3 is good. They didn't integrate. Yeah, we integrated secant squared correctly. Step 4. We moved over the 3. It was divided by 3. So we multiplied both sides by 3. So now it's just 3 tangent x plus c. Yeah, that works. Like, we don't need the 3c there. The c is a constant. So we're good there. And then step 5, we got to get rid of the cube. What's the opposite of cubing something? Cube root. That's what we did. Step 5 is fine. Okay, we don't need plus or minus when we take a cube root. Cube root is just going to be plus. So Jackson's work is correct. He did not make a mistake there. Notice that we separated, we integrated. We didn't solve for C because they didn't tell me a point. I've never really seen them ask that. 98% of the time when you do a problem like this, you're going to solve for C and then solve for Y. Here they didn't. We'll be okay. All right, let's go ahead and pull out your notes from Friday. We're going to complete those. We are solving differential equations. Remind your neighbor, what are the 5 steps of solving a differential equation? There are 5 steps to solving a differential equation. S-I-C-Y-O. S stands for separate. I stands for integrate. C stands for solve for C. Solve for C. Solve for C. What does the Y stand for? Solve for Y. Don't write this in your notes because, well, you can. Just be careful. We're going to run out of space. What's O stand for? Options. Options is when you have plus or minus. So we separate, we integrate, we solve for C, we solve for Y, and options. That is how we solve a differential equation. A reminder that they could ask this question in a bunch of different ways. I hate this question because my students get super worried about the wording. Consider the differential equation. All right, cool. That just means they gave you dy over dx is equal to something. Find y equals f of x, the particular solution to the differential equation with the initial condition. That's a lot of words to say what? What are we trying to do? Solve for y. That's it. And it tells you that right here. Find y. That's all they could have had to say. Find y with f of 0 equals 2. That's all we really need to do. We need to figure out what y is. All right? So this is a question that was on the AP exam a couple years ago, and I felt like my students were really good at them. And then they did this question. They came back, and they're like, I had no idea what to do. Okay, it looks a little bit different. Okay, so today we're going to look at a little bit different problems and see if we can still do everything. Okay, so step 1 here is separate. We've got dy over dx equals 10 minus 2y. I want to get all the x's on one side, all the y's on the other. How would I get rid of the dx? Multiply by dx. Now watch this. I'm multiplying this whole thing by dx. And then I want to get the y's on the same side. So looking at that setup, what am I going to have to do to get the y's on the same side? I can't add it because it's got the dx with it because I multiplied by the dx. I need to divide by that whole thing. So all that's going to be left on this side is dx, and this whole side is 10 minus 2y. That is something that you would just miss at first glance, but it's because of that idea that I've got to multiply by the dx. If you throw that in parentheses, it'll make sense a little bit more. Anybody got issues with that first part? That was step 1, we just separated. Step 2, we're going to integrate both sides. Okay, I've done this differently in the past. I'm just going to do it the way that you probably would integrate this thing. On the left side, it is dy over 10 minus 2y. Okay, don't let that dy on top bother you. Remember, if that dy is right there, I could take that dy and write it right there and it not do anything different. So it's 1 over 10 minus 2y. That's what I'm trying to integrate. What is the antiderivative of 1 over something with y to the first power? That is ln. This is just a simple ln over here on the left side. Now, there's going to be some parts to that, but it is ln. Absolute value, 10 minus 2y. I need something else in front of that natural log. Talk with your neighbor real quick and figure out what it is. All right, we set this thing up. What needs to go in front of that? Anybody confident in what needs to go in front? A negative for sure. There's something else. A 1/2. Good. Negative 1/2. Because we just did mental U sub technically. What is the derivative of that inside part? -2, and then we have to divide by the derivative. So we divided by -2. That's why I got negative 1/2. Everybody all right with me on the left side? The right side, we just had this discussion. Okay, it says dx, but really what it is saying is 1 dx. There's a 1 there. What is the antiderivative of 1? X, because it's on the dx side. The antiderivative of that is going to get me x. So that is what's happening over here on the right side. Okay, that over here is x. What else do I need? Plus c. Separate. We integrated. We're up to 3 points on the AP exam. You only got to score 40. We already scored 3 just on this part right here. And this one's a tough one. Don't be discouraged if this one at first, the second day you've ever done these problems, you're not great at it. Separated, integrated. Now we are going to solve for c. We're going to plug in what we know. My x is going to be 0. My y is going to be 2. So it's negative 1/2. Natural log 10 minus 2 times 2 equals 0 plus c. So my c is going to be negative 1/2 natural log of 6. Questions there? Once I've solved for c, Jesse, what am I going to do next? We're going to rewrite it. We're taking the c right here. We're plugging it back in. So let's rewrite that. It is negative 1/2 natural log, absolute value, 10 minus 2y, absolute value equals x minus 1/2 natural log of 6. Ugh, it looks terrible. We'll be fine. Don't let the abundance of stuff throw you off. Remember, we've already scored 4 points. This last part is only 1 extra point. So if you get lost here at the algebra at the end, remember it's not that many points here at the end. We've done the most important stuff. We are trying to solve for y. We want to get y by itself. So Luke J, what do you want to get rid of next? Yep, negative 1/2. How do I get rid of that negative 1/2? Multiply both sides by -2. So we're going to multiply that by -2 and that side by -2. On the left side, those two things are going to cancel. So it's just natural log of 10 minus 2y. On the right side, I got to distribute it. So it's going to be negative 2x. And that's just going to cancel. So it's going to become plus natural log of 6. We're just getting rid of layer by layer. We got rid of the -2. Austin, what do you want to get rid of next? Not yet. What's on the outside of that? I got to get rid of the ln first. I got to take piece by piece. So if I want to get rid of ln, what am I going to do to get rid of ln? Yep, raise both sides to the e power. So this whole thing is to the e. This whole thing is to the e. What's going to happen when I have e and ln next to each other right here? Cancel. So I'm just left with the absolute value of 10 minus 2y. On the right side, it is e to that. You could leave it just like that, but it gets a little bit ugly. Okay. Instead, I could also write this as e to the negative 2x. And what could I do if I have e and in my exponent I have plus natural log of 6? I could multiply by 6 because we could separate this. Remember, this is the same thing. We talked about this on Friday. That right there is the same thing as e to the negative 2x times e to the natural log of 6. Okay, so those would cancel. That's where I get that 6 in front. If you don't remember that, go back to Friday's notes and look at it again. We got to this point. Slade, what do I want to get rid of next? How do I get rid of absolute value? I'm going to do plus or minus on both sides. That is the absolute value killer. So now we got 10 minus 2y equals plus or minus 6 e to the negative 2x. It's annoying, but we're going piece by piece. Aiden H, what am I getting rid of next? The 10. How do I get rid of it? Let's subtract 10. What else do you want to do? Yep. So he's got negative 10 plus or minus 6 e to the negative 2x. He also said we can divide by negative 2. So divide by negative 2, divide that by negative 2, divide that by negative 2. So I get y equals negative 10 divided by negative 2 is 5, plus or minus 6 divided by negative 2 is negative 3, but it's already plus or minus, so who cares if it's negative, it's plus or minus. E to the negative 2x. We separated, we integrated, we solved for c, we solved for y. The last step we have here is options. Talk with your neighbor. Decide if that needs to be a positive or a negative sign. Thumbs up if you think it's positive. Thumbs down if you think it's negative. Getting a lot of negatives. Let's check. I'm plugging in 0, and when I plug in 0, I'm supposed to get 2. So if I plug in 0, e to the 0 power, what's e to the 0 power going to get me? 1. 3 times 1 is 3. Do I want it to say 5 plus 3 or 5 minus 3 if my answer needs to be 2? Minus. It is 5 minus 3. That is my final answer to that question. Separated, integrated, solve for c, solve for y, options. I would say that's probably one of the meanest ones I've ever seen them give, but that was on the AP exam, I think, 2 years ago. All right, that one's a little bit rougher, so you got to kind of take your time there. Questions on that? Let's go to the next one. dy over dx equals x times y squared. Remember, this thing right here, you could do this, dy over dx, just like we did in bell work. That is the same thing as x squared, y squared. Right, I'm just squaring both things. Go ahead and separate it, see what you can do. Yeah, we did. First thing we're doing is we are separating. So if we're separating, what'd you do here to separate, Evan?
I divided by y squared and multiplied by dx.
Good. Divide by y squared and multiply by dx. I hate saying over y squared. So what else could I write instead of writing divided by y squared? Y to the negative 2 equals x squared dx. That's my first step. We separated. A and B, what am I going to do next? Integrate it. Let's do it. If we're integrating both sides, Aiden, what's my new exponent going to be over here? Negative 1. What's my new leading coefficient going to be? Negative 1. Wonderful. On the right side, we are taking the antiderivative over here. What's my antiderivative on this side going to be, Taylor? Yep. X to the third power, and then divided by our new exponent is 1/3. What else do we need? Plus c. Go ahead and find your c value. Show it to me with your fingers when you find it. Good. We're doing well here. We're solving for c. So I'm plugging in 1 and 1. So everywhere there's a y, I'm plugging in 1. Everywhere there's an x, I'm plugging in 1. What is negative, or what is 1 to the negative 1? What's a negative power do? Flips it. So I flip it. It's still 1, and then I make it negative. So this is negative 1. 1 to the third power is 1 times 1/3. So it's 1/3 plus c. Last thing I got to do is subtract 1/3. So if I subtract 1/3, negative 1 minus 1/3 is going to get me negative 4/3. I would always suggest writing them as fractions. It'll just be easier. Okay. Negative 4/3 is c. I separate, I integrate it, I solve for c. Then I'm going to take this right here. I'm going to plug it in right there, and I'm going to solve for y. So I get this. Negative y to the negative 1 equals 1/3 x cubed minus 4/3. If you wanted to get crazy, you could write this all as one fraction. Okay, if you wanted to, off here, this is, since it's both divided by 3, you could make this x cubed minus 4 all divided by 3. Everybody see what I'm doing there? Since they're both being divided by 3, you could do this. You don't have to. I want to get y by itself. So if I want to get y by itself, Cannon, what do you want to get rid of next? The negative sign. What are you going to do to the right side if you're getting rid of the negative sign? Change the signs. Cool. I get y to the negative 1 is equal to that. I still got to get rid of my negative 1 power. What does a negative 1 power do? It makes it a reciprocal. So how do I get rid of a negative 1 power? Do the reciprocal. Technically, the way you do that to get rid of y to the negative 1 is you raise it to the negative 1. Because negative 1 times negative 1 would be just 1. It would go away. Okay? So to do that, I'm raising this side to the negative 1. I'm doing the reciprocal. You could write that and just write it to the negative 1 power. Or you could write it as 1 over this whole giant mess. Or if you would have written it this way, where you would have written it as one fraction, then you could have flipped it and just made it 3 over negative x cubed plus 4. All of them are the same. It doesn't matter. It's calculus. We don't have to simplify. So 98% of you are probably going to leave it just like this, and that's perfectly fine because I got the right answer. Questions on how we do that. To get rid of a negative power, we do the reciprocal. So you got to just write it as 1 over that whole exact thing on the other side. Yes, ma'am?
I just have a question about when we did the top one, or the example number 5.
Yep.
You had the dx, you moved that first, you had it from C.
Mm-hmm.
Why didn't we do the same for this one, like we did the y?
It does. That part wouldn't matter. This dx on this one, to get rid of the, if I would have added the 2y first, you technically can get the same answer doing it the other way.
Okay.
So you could have done it that way. I like doing it that way cleaner. It's easier for me, but technically we could have moved the 2y over, I guess. Yeah, I'd rather do it that way though. All right, let's go to whiteboards. You got whiteboard sitting on your desk today. We are just going to do kind of a speed round here. We're not doing the whole problem. Okay, if I did the whole thing, it would take a long time, but we're going to work on just separating, integrating, and that's it. Separate and integrate. Okay, see if we can do those two things correctly. So on your board here, you've got this problem. Separate and integrate it. Go. We are separating first, so to separate. Okay, to separate, we're going to multiply both sides by 3y. Multiply by 3y. That's going to go away. We just had this discussion, and I just said it a second ago in the video, but when we're moving the y's over, you always want to multiply or divide the y's over. We don't want to add or subtract. It'll cause issues in other ways. Okay, so do not add or subtract y's. Obviously, you're not going to do that here. And then we're going to multiply by dx. Boom, boom. We get 3y dy equals 2x plus 1, and that is all times dx, which is what I want. Okay, don't let those parentheses overwhelm you, but yeah, that's what I want. I add 1 to my exponent. I divide by my new exponent. 2x, I add 1 to my exponent. I divide by my new exponent. And then don't forget about the 1. I add 1 to my exponent. It's just 1x and a plus c. You got to have the c because otherwise you can't do the next part. It's separate, integrate, solve for c. You got to have that c part. Questions on the first one? Next one. dy over dx equals 2y minus xy. At first glance, this one's yucky. Why do we not like it right now? There's 2 y's. We don't want there to be 2 y's. We want to be able to write that as a single y on the right-hand side. What could we do before we separate them that will make this problem easier to work with? Factor a y out. If it's 2y minus xy, you can do that first. Separate and integrate and then show it to me. Good. We didn't do too bad here. First thing we're going to do is we're going to divide both sides by y. So I'm getting dy over y. Okay, or 1 over y times dy equals, that's going to cancel. I'm going to multiply by dx on both sides. Okay, 1 over y. What am I going to get if I take the antiderivative of 1 over something to the first power? This is natural log, absolute value of y. You got to throw the absolute values, otherwise you're going to have issues at the end. Then we're integrating. Add 1 to my exponent, divide by my new exponent. Add 1 to my exponent, divide by my new exponent. Don't forget your plus c. Questions on that one? Next one, dy over dx is equal to e to the x plus y. At first glance, it's kind of tough to deal with. What can I do to separate that y? We don't, yeah, I'm hearing some of it. We don't want to use ln, because if we use ln, then we have to take the ln of this side, and no, that's bad. We don't want to have ln of dy dx. That looks terrible. Instead, I'd like to just be able to rewrite the right side. How can we rewrite that at? What can we make that the same as? E to the x times e to the y. Because remember, x to the 2 plus 3 is the same thing as x squared times x cubed. Those two things are the same. So this is the same thing as that. If you get to that point, now you can separate and integrate. Go ahead and separate and integrate for me. If you can separate and integrate, you're scoring 3 out of the 5 points. You haven't done anything else. All we're doing is separate and integrate, and we're getting over half the points. When we set this thing up, we are going to divide by e to the y and multiply by dx. And so if I divide by e to the y, you could write it like this, but we don't want to write it like that. I don't like when it's in the denominator. I don't want denominators. How else could I rewrite e to the y if it's in the denominator? E to the negative y. Now I can take the integral. So that's just separating. Now I'm going to integrate. The antiderivative of e is what you see, but I have to divide by the derivative of the exponent. So what else do I need to include here? A negative sign. On the other side, the antiderivative of e to x is e to the x. Okay, we got a plus c at the end. Boom, done. Questions there? One more. Separate and integrate it. Okay, separate and integrate it. Then we'll check, and then we'll go from there. Here we go. We are finding the antiderivative. So when we do that, we're going to multiply by dx. Multiply by dx. I have to divide by y to the fourth. So dy, I could do divided by y to the fourth, or I could just say, hey, that's y to the negative fourth. On the right side, it's just dx. That's separate. Now we're integrating. Okay, to integrate that thing, I'm adding 1 to my exponent, and I divide by my new exponent. I integrate dx. Remember, that says 1 dx. So if it says 1 dx, what's the antiderivative going to get me? X plus c. Solve for c. Show me an answer. Solve for c. Then hold it up. We had some issues here with negative signs as we're plugging in. We are plugging in the point 2, and we're negative 1. So if we plug in negative 1 here, over here it's negative 1 to the negative third power equals 2 plus c. Negative 1 to the negative third power is going to stay negative 1 times negative 1/3 is negative 1/3. Positive. It's actually positive. That's negative. It's positive. That's positive 1/3. That is going to be equal to 2 plus c. So what do I need to do to get rid of the 2? Minus 2, minus 2. So it's like minus 6/3. So 1/3 minus 6/3, my bad, is negative 5/3. Okay, a lot of places you can make mistakes there with your negatives. There's a whole bunch of stuff going on. Questions to that point? Let's just finish this one together. So that way we can do it in a little bit of time here. We take this, we're plugging in here. Negative 1/3 y to the negative 3 equals x minus 5/3. I'm trying to get y by itself. So what am I going to do next here, Caden, to get y by itself? Yep, let's multiply both sides by negative 3. That's going to cancel with that. We got to multiply this whole side by negative 3. So I get y to the negative 3 equals negative 3x plus 5. Because when I distribute that in, it's going to become plus 5. Everybody good to this point? What do I need to get rid of next? The negative 3. And you can try to get rid of it all at once if you're good enough, but sometimes we struggle with that. What would be the opposite of raising something to the negative 3 power? Yeah, see, that's my issue. Not a lot of people know that. So let's get rid of the 3. How do I get rid of a third power? You cube root it. To get rid of the third power, I'm going to cube root it. So I'm going to have y to the negative 1, because I didn't get rid of the negative 1. I got rid of the 3. Okay, the cube root over here is going to be the cube root of negative 3x plus 5. I still need to get rid of the negative 1 power. How would I get rid of the negative 1 power? Reciprocal. Take the reciprocal of both sides. That is going to be my answer. Technically, to get rid of a negative 3 power, you could raise both sides to the negative 1/3 power. That is what would cancel out a negative 3, because it would change to positive and it would get rid of the 3. But you could also just cube root and then flip it. Questions on that?